So we're going to talk about intersections of polar curves. Now, one of our classes got through the first page of this, so if you did, you can just skip ahead to the second page. But we're going to go through this. So we are going to, just like we do with algebra, two lines, where do two lines intersect? They intersect. The solution of two lines is where they intersect. Just in the same way with polar curves, the solution of two equations, of polar equations, is where they intersect. What do we do with two lines? There's three ways. Elimination, substitution, and graphing. Same thing here. So we're going to graph and we're going to use substitution. Okay? So let's do graphing first. R equals 1 is a circle. R equals 1. There we go. So if I want, then we're going to do, that's the first equation. Let's do the second equation. So with the second equation, we have R equals 2 cosine theta, also a circle. Now we have the second circle. It has a diameter of 2, and it's going to be right here. So we see, I may not have drawn that perfectly, but let's hope it gets pretty close. R equals 2 cosine theta is going to intersect at 2 points. It's going to intersect at this point, pi over 3, and the point 5 pi over 3. Yeah, I did pretty good. Okay, that's the 2 points where this graph intersects. We see it when we graph it. That's one way. Now we have to also be able to find it algebraically. So we're going to do that with substitution. So if we take R equals 1 and substitute that in here, we can find theta and see the solutions algebraically. So 1R equals 2 cosine theta. All right, solving for theta, we divide by 2. Those 2's cancel, and we get cosine theta equals 1/2. Okay, well, for what value theta does the cosine equal 1/2? Well, if I remember my unit circle and I'm drawing a angle on the unit circle and I say, okay, the cosine is the adjacent side, and for what value of theta? Well, that would be 2. Remember, there's always two values where the cosine is positive 1/2, and that would be, okay, all students take calculus. When is cosine positive? In the first and the fourth quadrant. So theta is 1/2 for pi over 3, 60 degrees. Pi over 3 and 5 pi over 3, or 60 degrees. And where is 60 degrees from the horizontal? Pi over 3, 5 pi over 3. Excuse me. So I need to write this as coordinate values, right? So remember that on the polar graph you have r theta, okay? R theta instead of xy, okay? So what was my r? My r was 1, okay? 1 pi over 3, and because look where it is. And let's look at my graph again. What was r? R was 1. 1 pi over 3 and 1 5 pi over 3. So those are my intersection points, and I'm not doing that very well. Okay. Excuse me. Okay. Now there's one other way I could do this. Let me just bring this up. I could turn these equations into rectangular equations. R equals 1. If I could square both sides, R equals 1. R squared equals 1. Let's square both sides. This could be x squared plus y squared equals 1. And I could then take the other equation, R equals 2 cosine theta, multiply both sides by r and get r squared equals 2r cosine theta, and then this would be, I could change r squared into x squared plus y squared equals 2x, And now I have two equations, both in rectangular form. So notice that I could, from the rectangular form, find where they intersect, okay? And find their rectangular coordinates where they intersect. And if I do that, they do intersect. I'm not going to do that here, but I could do that, and they intersect at 1/2 radical 3 over 2 and 1/2 negative radical 3 over 2, which is exactly where you would expect them to, because those are the points on the unit circle where they would intersect. So you can do that because you can convert from polar to rectangular. Okay, let's do the next problem on the page. So I'm going to first sketch, then use substitution. So r sine theta. Now notice that this is r1 sine theta. So that is a circle above the unit circle right there with a radius of 1. Now what is r equals 1 minus, notice 1 sine theta? A equals b. A equals b, so what is that? Well, that would be a cartoid with a negative, so that's going to be this heart shape, a plus b all the way down here, so that's going to be a cartoid. So we see that we have intersection points here, here. Now, notice that I have what looks like another intersection point here, and this brings up another point for these type of graphs. There is a possible intersection at 0, 0. When you're solving for polar equations, you may if you solve algebraically and you find solutions, but then you graph them and there looks like there's another apparent solution, which there will be for this graph, but you don't find it algebraically, then the third solution is what we call a common point, and it is not a solution. And it is not a solution. So let me show you what I mean by that. Let's use substitution to figure this out. So using substitution, we substitute sine theta for r. Okay, substitution. Sine theta equals 1 minus sine theta. We're just going to solve for theta. Okay, using algebra. Now we're back to algebra. What are we going to do? We're going to solve for theta. So let's combine the thetas. Plus sine theta plus sine theta. This algebra. So these cancel, and I'm left with 2 sine theta equals 1. Trying to get sine theta. Now I'm going to divide by 2, and I get sine theta equals 1/2. So now I ask myself, just like I did before, for what values of theta is the sign positive? All students take calculus. Sine is the opposite, so, and I didn't draw that very well. The sine is 1/2 for 30 degrees, so theta is pi over 6 and 5 pi over 6. So that is the correct value of theta. So what are my, what is r? Well, r is 1/2. Okay? So we look at our point, and what is r? R is 1/2. Okay? When we look at our graph, we see that the r value is 1/2. So our solutions are 1/2 pi over 6 and 1/2 5 pi over 6. Okay. So I found my algebraic solutions, and now I need to account for this 0, 0 solution. This 0, 0 solution exists on the graph when I graph it. The point 0, 0 is an example of a common point and is not a solution. So that is, we can't count it as a solution. It's called a common point. Okay, so let's do it again. We have to be able to differentiate for that. Okay, so we're going to do this again. Graph each system of polar equations and solve the system algebraically. So we're going to look for more common points. Intersections and indicate if they are a solution or a common point. So let's graph it first. We have 4 cosine theta. So positive cosine theta. Let's do the easy one first. So that would be and this is, we want to be careful because it's hard to, we know it's 4 on this axis. We're just doing sketches. Now 2 plus 2 cosine theta is a cartoid, right? Because A equals B. We know that we're going to have the intersection of 2. We know that it's positive, so we know that, and we know, so it's going on the graph this way. A plus B is 4. So it's going here. Okay. So there is a sketch of where the graphs intersect. Okay, so now let's do an algebraic and see exactly where they intersect. So we're going to say 4 cosine theta equals 2 plus 2 cosine theta. What are we going to do? We're going to start combining so we can see. Let's subtract 2 cosine theta to get these together. These cancel. Get 2 sine theta equals 2. I want to get rid of the 2's. And I get, excuse me, I'm going to divide by 2. And I get cosine theta equals 1. So I ask myself, I'm going to draw a little unit circle and ask myself where 1, 0, where is the where is cosine equal to 1? So theta is equal to 0. That's where the cosine value equals 1. Sorry, I wrote theta, but I meant 0. Theta is equal to 0, the value of 0, and r equals 4. So my point is 4, 0. The common point, the origin is a common point. Because the origin is your common point. So where theta is equal to 4 is your actual solution, where the origin itself is your common point. All right. I want you to do the last problem on your own. Let me get you started. You're going to have an r equals -3, and you're going to have a rows for this problem. So you're going to have to graph the rows. Remember, when you graph rows, you have r equal to 3 and r equals -3. So go ahead, start graphing. 3 equals 3 cosine 2 theta, and negative 3 equals 3 cosine 2 theta. Go ahead and start graphing that. Come up with your common points and your solutions. Okay? All right, I will see you in class.